Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/43 for the session May June 24. And we are going to solve the last of all questions of this paper. Let's read question number 7. The diagram shows a track ABCD which lies in a vertical plane. The section AB is a straight line and inclined at an angle of 30 degree to the horizontal and is smooth. The section BC is a horizontal straight line and is rough. The section CD is a straight line inclined at an angle of 30 degree to the horizontal and is rough. The lengths AB, BC and CD are each 2 meter. A particle is released from rest at A. The coefficient of friction between the particle and both BC and CD is mu. There is no change in the speed of the particle when it passes through either of the points B or C. It is given that mu is equal to zero point 0.1. Find the distance which the particle has moved up the section CD when its speed is 1 meter per second. So it's one of the longest questions. Well, step by step we will have to solve this question. First of all, we will have to understand that among these three parts, look at this AB, part AB, that means the plane AB, straight line AB is smooth. Okay, this is one of the information we can pick up. BC and CD are rough. Look, BC and CD are rough because it is written here CD is rough as well as BC was also rough. So these are the information initially we can pick up, and we know what to do for solving this. We will apply the concept of the motion laws of Newton, but before that we will have to obtain the supporting information. Well, before doing anything, first of all I will have to complete the diagram. Let me complete drawing the diagram. Suppose this is our diagram. Yes, let's draw the triangles. This one, yes, here first part AB. This is the particle is over there. Suppose particle is over here. Let it be over here. So what will be our normal reaction is this one is normal and weight is acting vertically downward. Here is the angle is 30 degree. Angle is 30 degree. Well, let me erase this unwanted part. This part is not necessary. Well, then for the second part, let me erase this part also. This is not even necessary for us. Well, okay, then for the part BC, for the part BC it is actually a vertically straight line, horizontal line. That's why we will have to just draw a straight line. It will show the direction because weight and normal reaction force lying on the along the same vertical line. Okay, then the second part, this is the normal force and weight is acting downward. Now let me draw it once again. Yes, this way we can show, and the angle at which it is inclined is also 30 degree. Well, this may be the scenario or diagram of this whole of the system. Okay, first of all, as we have seen that the section BC, and CD are rough. Look at this, except AB. AB is smooth, but for BC and CD they are rough. Okay, as they are rough, first of all we will have to find the normal reaction force. Okay, so for BC, normal reaction force, for for the section BC. For BC, there will be different normal reaction force, because look at this, BC is lying straight along the horizontal road, whereas CD is inclined at an angle of 30 degrees. So definitely normal reaction force will not be same in both cases. Okay, so for the part BC, normal reaction R plus, there is no upward force, that's why it is 0. Let's see what is the downward force. Downward force, we know that mg cos 0 degree. Okay, because it is straight enough, as straight as the horizontal line, so angle will be 0 degree. So G is what? Our G is going to be acceleration due to gravity, which is 10, and M is mass, and cos 0 is 1. So it is going to be just simply 10m. This is the first normal reaction. And for the second one, using different for for CD. Okay, for CD, if we calculate R plus 1, R plus 0, because there is no upward force acting on the particle, but downward force is this, is mg cos how much? Cos 30 degree. Cos 30 degree. So hence our R, second R normal reaction is going to be, m is mass and acceleration due to gravity, G is 10, cos 30 is root over 3 over 2. So 10 square root over 3 over 2 m. That means it is 5 square root over 3, 5 5 square root over 3m. 5 square root over 3m is the second normal reaction. Okay, so we have got some of the required information from the diagram. Well, now one after the other, as there are three parts, so one after the other we will have to find the forces acting on that. We are going to resolve the forces. So from the first part, from A to B, let's see from A to B what are the forces acting on this. And we have already decided that motion law, concept of the motion law of Newton is going to be applied. That means driving force minus, as it is sliding down, so it will be the direction. Driving force minus resistance force is equal to mass into acceleration from A to B. So let's see what is the scenario from A to B. This is A. When it was moving downward, look, there is no driving force acting on this external driving force. There is no external driving force because particle was released. Look at this here, particle was released from rest at A. So what is the driving force acting along this horizontal axis? What is the force? This is weight. Only weight is acting as driving force here. So we will find horizontal force, horizontal component of weight. What is the horizontal component of weight? We know that is mg sine, as angle is 30 degree, it is going to be 30 degree, minus resistance force. Look, as the section AB is smooth, we have already marked it, section AB is smooth, so there is no frictional force at all, and as there is no other external force also, it is going to be 0, nothing but 0. And mass into acceleration, let us see from both sides. If we get m dissolved from both sides, acceleration due to gravity, G is 10, sin 30 is half, so it is 10 over 2, and m can be dissolved from both sides, it is A. Hence our acceleration of the particle at the point B is 5 meter per second. 5 meter per second. So we have solved one of the parts. Let's see about the next part. So changing our ink, we can write from B to C. From B to C. Remember, we will have to solve the question stepwise because there are three different parts with different coefficient of friction. B2, C, all of the sections are neither smooth nor rough. So individually we'll have to calculate them. B2, C. The same concept as it is horizontally straight, it is moving to the forward direction. So driving force, the same concept, driving force minus resistance force. But before that, driving force minus resistance force is equal to mass into acceleration. Well, so what is the driving force of this particle? Look at this. When the particle was released from A, it was just moving onward without any external force. So there is no driving force at all. Okay, driving force, there is no driving force. Now resistance force. What is the resistance force? First, resistance force may be calculated as weight here. So weight may cause resistance to the motion. In that case, how to calculate weight? We calculate the horizontal component of weight is mg cos, no, not cos, it is sine 0 degree. This is a vertical in terms of triangle. So mg sine 0 degree, because it is, the angle is 0 degree, it is lying horizontally straight. Then another negative force, frictional force. Frictional force, we know that frictional force is what? Mu r. Mu r is equal to mass into acceleration. Well, then our negative acceleration due to gravity is g sine 0 is 0. So mu is frictional coefficient. How much is the frictional coefficient is given? It is zero point 0.1. So zero point 0.1 and r for this from B to C. This is our r. This is our r from B to C. It is 10 m. Well, so it is going to be 10 m and our mu is zero point 0.1. So zero point 0.1 into 10 m. M can be dissolved from its cases, is equal to mass into acceleration. M has been dissolved. So it is, A is going to be our, hence our acceleration is, if we multiply this, it is going to be negative 1 meter per second square. So acceleration at point C. Okay, we have completed two of the parts. Okay, then we will complete the third part also. So from B to C, changing our ink, from C to D, the last part, from C to D. Okay, from C to D, same way, driving force minus resistance force is equal to mass into acceleration. What is our driving force? Actually, there is no driving force at all because we have already calculated two times. The particle was released. There is no external force acting on this. Then the resistance force. Let's see what is the resistance force. This is C to D. Look, at C to D, weight is causing resistance to motion. So how to calculate weight? We know weight is mg sine, and angle is how much? 30 degree in both cases. Okay, then another force acting as resistance to motion, which is frictional force. Frictional force is mu r. Well, equal to mass into acceleration. I think I should write on the left or right. No. Let me see whether I do have sufficient space on the right side or left side. I think it's better I complete writing on the left side. Okay. So if I use the left part, let me draw one line, divider line. Yes. So left side there is, if it is not visible well, so let me show you. It is 0 minus, okay, 0 minus, 0 minus what? Just let me try to write with small font. Okay, 0 minus 0 is not necessary to be written. So minus, here mg sin 30. Sin 30 is half, m g is 10, and m can be dissolved from every side or every quantity. So it is sin 30, that is half 10 over 2, 10 over 2 minus mu r. Mu was what? We have already calculated. Mu is 0.1, 0.1, and r is our frictional force. We have already calculated our frictional force for the section CD. Our frictional force is this. R is 5. R is 5 square root over 3m. 5 square root over 3m. So this is 5 square root over 3m. M has been already dissolved, equal to right side is ma. So m has been dissolved from every quantity, so it is just a. Well, after that, yes, then it is going to be negative 5, negative 5, and if we multiply this, it is going to negative 5, and it is 0.5 root over 3 minus 0.5 square root over 3, square root over 3, square root over 3 equal to a. Okay, so finally I have got that it is minus 5 plus 5 plus 0.5 square root over 3. So this is the acceleration. So we have got three different acceleration at three different points. So first acceleration is, this is our first acceleration. First acceleration was a equal to 5 meter per second. Then actually we are going to find the distance. If we look at the question, they told us to find the distance. Look, this is our final step. We are going to find distance, and for distance, the simple concept of Shubert formula, that is v square is equal to u square plus 2 as, we are going to apply that formula. So one after the other, remember, at all points, since the acceleration is different at different points, so velocity will also be different at different points. That's why one after the other, first of all, velocity at b, we will find a velocity at b. Let me write just on the right side. Let me draw a line over here. Okay. Now first of all, we will find the velocity at b. velocity velocity at v at b. How will we write? We will write, we know the formula we are going to apply is v square is equal to u square plus 2as, isn't it? So it is u square plus 2as. Okay, and velocity at v is to be obtained, so v at v is going to be square root over u square. Initial velocity was 0 because the particle was released from rest, so 0 and plus 2. Let us see, acceleration at v was what, 5. So 2 into acceleration is 5, and displacement, let us see the displacement or distance or length of each of the part, it is written loop. Each of the part A, B, B, C, C, D is 2 meter loop. This is 2 meters. So every section has a length of 2 meters. So everywhere we will use 2. It is going to be 2. Well, hence V velocity, final velocity at V is equal to what? 420. So 2 square root over 5. This is at B. Well, now we will find at C. For that, let me change the ink. So V square at C. V square at C is the same concept, U square plus 2AS. Okay. Then let's see, it was at B. At, no, changing my ink, it shows better. So at B. This was at B. Now at C, at the point C. At C. For that, I will have to erase this. We'll find the velocity at C. At C. Okay, at C, velocity at C is equal to the same concept, U square plus 2AS. Okay, it is all about C. Let's see what was the acceleration at C. Yes, acceleration at C is this one. Look, this is the acceleration we have got at C. It was what? Negative 1 meter per second. So if we apply this, hence our velocity at C is equal to, I will have to zoom it out. So at C, our velocity was what? 1 meter per second, negative 1 meter per second. Let it be applied here, equal to square root over. Initial velocity was what? This is the initial velocity at B. So it is 2 square root over 5 square, and minus acceleration was negative and it was 1. Displacement is 2 because we have already seen that each of the part is of length 2 meter. So if we calculate this, what is it going to be? V at C, final velocity at C is going to be, this is 4, 5, 20. 20 minus 4 means 16. So it is actually 4. It is going to be 4 meter per second. Okay. 4 meter per second at C. Okay. Now last part at D. At D. At D. Okay. At D, the same concept. The concept is V square is equal to V square V at D, not D. It was actually the particle didn't reach D yet. We are writing, uh, okay, we may write a different point over here. Yes, D was at the bottom. Suppose the particle could reach up to this point. Okay, up to this point, and we may suppose it to be at E. Okay, so we will write VE. Instead of D, let's write, already D is given, so it will be VE. It is E. At E. At E. Okay, at E, velocity of E, the same concept is U square plus 2AS. Well, now our U was, initial velocity was what? Hence VE is equal to, hence symbol should not be over here. Okay, initial velocity was, what is the initial velocity? initial velocity was 4. So 4 squared, then plus, let's see what was the acceleration at point E. Look, final acceleration was, we have calculated here, final acceleration was, it was negative 5 plus zero point 0.5 root over 3. Okay, so we will apply this 4 square minus 2as, 2 into a s is already 2, and our acceleration was 5 plus, what was it, 5 plus zero point 0.5 root over 3, 5 plus 4, zero point 0.5 over 3, 5 plus 0 0.5 square root over 3. So this is what our final velocity. Then no, I think we could have written, this is the final stage, so we could have written here, let me erase this, and the square root symbol is not necessary. So let's erase the square root symbol, because as we require s is not given here, because we don't know how much was the length the particle moved up. Okay, so it is going to be v square, sorry. Yes, it is v squared. The concept is v square equal to u square plus 2as. Or if we calculate this, look at this, what is it going to be? Yes, here. Or final velocity at E we have already obtained, which was, no, initial velocity was 4, but final, I will have to write it once again. Okay, so let me erase this part actually. I will have to write it again because it was really messy. Okay, the concept we are applying is, what is the concept? V square is equal to u square plus 2as, isn't it? 2as. And we look at this final velocity is given. What is the final velocity? Let's see. They have told to find the distance which the particle has moved up the section CD when its speed is 1 meter per second. So final velocity is given as 1 meter per second, and initial velocity was 4 meter per second. So we can use 4 square, final velocity was 1 square, and as acceleration was negative 2, s is to be obtained. Let's write the acceleration at E. It was the acceleration, negative acceleration means deceleration. It was 5 plus zero point 0.5 root over 3, 5 plus zero point 0.5 root over 3, 5 plus zero point 0.5 square root over 3. So this is what our acceleration. Well, now if we simplify it, what are we going to get? Look, after simplification, 16 minus 1, it is going to be, sorry, here we made a mistake. Look, final velocity, initial velocity was 4 square, final velocity was 1, initial velocity was 4. So final velocity was 1, whereas initial velocity was 4 square, initial velocity was 4. Okay, so it is going to be 1 square means 1. If we subtract 14 from, I mean 4 square means 16. Well, it is 4 square. Okay, if we subtract 16 from 1, it is going to be negative 15, equal to negative negative 2 into s into 5 plus 0.5 square root over 3. We require s, so let's isolate s. I don't have any space to write anywhere. Okay, we require s. I think I can just write, let's take a new page. Or is this place sufficient? I think I can continue writing over here. Look, here our s is equal to, on the left top side, s is equal to, look, our s is equal to, negative symbol will be cancelled from here, then it's going to be 15 over 15 over 15 over 15 over what, 2 into 5 plus, so what is it going to be, 2 5s are 10, so 10 plus root over 3, 10 plus root over 3, 10 plus square root over 3. That is our displacement. Hence, the displacement traveled by the particle along CD, along the plane CD, it is going to be S is equal to 15 plus 10 plus square root over 3. 10 plus square root over 3, that is 1.277. So it's 1.28. If we round it up to three significant figures, it is 1.28 meter. So this is the final answer to this solution. That means the particle traveled 1.28 meter when it was moving up along the plane. 1.28 meters. So that is what the solution to the first part of this question. And it seems to be very messy because there is a shortage of space to write whole of the solution on the same page. This device doesn't allow to write so much on a single page. So let me draw a divider. Yes, this one is the final answer for finding displacement. So what have we done in this case? First of all, we have found the acceleration at every point. Acceleration at point, we have found acceleration at point B first. Then we have got acceleration at point C. Then we have got acceleration at point E. After that, we have got final velocity at B, velocity at C, as well as velocity at E. Then we have just applied the same formula, that repeated formula, v square is equal to u square plus 2as. From that, we have isolated S as subject. And thus we have solved this. It's a little bit lengthier, but remember, most of the forces concept have been applied here, so please don't make mistake while solving this. Let's solve the immediate next question. The next question is, the next question says, it is given instead that with a different value of mu, the particle travels 1 meter up the track from C before it comes in instantaneously to rest. Find the value of mu and the speed of the particle at the instant when it passes C for the second time. Well, there are two values to be obtained. One is mu and the other one is the speed, velocity when it comes back. Well, first of all, we will have to find the acceleration at different points. So we have not forgotten that the out of three parts, let's go back to that page. Out of three parts, first two parts are, first part A to B, it is all the same. Look at this, A to B is smooth. Yes, here it is written. Let me erase this. Look, A to B is smooth. So whether something is changed, I mean frictional coefficient changes or not, it's all the same. So from A to B, acceleration as well as velocity will remain same. So what is the change happening? It is happening from B to C. Okay. So from B to C, let us start with the acceleration at B. Okay, acceleration at B must be same as I have told, because this is always smooth. So acceleration at A at B is this 5 meter per second, and velocity at point B will also remain same. Velocity can be written later on. First we will write that velocity, I mean acceleration at B is same. So let's write acceleration. I can write just over here. Acceleration at A. Acceleration. Acceleration at B. At B, it's all the same. A is equal to what? 5 meter per second square. Well, now from B to C. From let me take blacking. From B to C is to be calculated. From B to C. B to C, the same concept, the concept of the motion law of Newton, we will write driving force, and this is definitely horizontal. This is horizontal movement. So driving force minus resistance force is equal to mass into acceleration. It's all the same actually. Driving force was nothing because the particle was released from rest. And if you calculate weight, it is going to be mg sine 0 degree. Sine 0 degree. Sorry, for if we talk about the weight causing the resistance to motion, then it is mg sine 0. We have written so on the previous page also. Let's say it was mg sine 0. Look at this, here we have written mg sine 0. Well, then if it is supposed to be the resistance to the motion, well, after that the third resistance to motion is the frictional force, and frictional force is mu r. Mu r equal to mass into acceleration. Mass into acceleration. Well, mg mass is not given. Acceleration due to gravity is 10 sin 0 0, so this is just 0. And mu r from B to C has already been obtained. Let us see how much was our r from B to C. Yes, here we have used r. Look at this, r from B to C. For BC, r was what? 10 m. This is the resistance force from B to C. So this is 10 m. Let us calculate 10 m. So it is going to be 10m. So 0 0 and then minus 10m is the 10m mu equal to ma. Hence our acceleration is, if we dissolve the masses, so it is going to be negative 10 mu. Negative 10 mu is the acceleration from B to C, meter per second square. Okay, we have got two acceleration, and then the acceleration at the final point. Okay, same way we will calculate this from where to where, from C until, let us see, the question has told, look at this, the question has told that the particle travels 1 meter up, 1 meter up the track from C before it comes instantaneously to rest. So we may suppose it to be at E. It didn't reach D. Here it has reached up to this, which is E. Okay. So and the distance of this from E to C is 1 meter. Well, it is 1 meter. So let's calculate from C to C to E. The concept is same, that is driving force minus resistance force is equal to mass into acceleration. Let's see what is the driving force. Driving force was actually nothing, because the particle was moving on its own, so it is 0. Resistance force is, there are two resistance forces. One is weight is causing resistance to motion. So what is the resistance due to the weight? That is mg. We know that is sine what, sine 30 degree, because it is 30 degree. Let me show you. It was inclining at an angle of 30 degree. Yes, look at this here, the angle is 30 degree, angle is 30 degree. So because we are calculating C to D, from C to, not D and E are same, it's all the same, so angle is 30 degree. That's why we have written mg sine 30 degree, mg sine 30 degree. Then the second resistance to motion is mu r, and r, due to r was also written, we have already found r at the beginning. So r from C to E, from for CD means from C to E, r was this 5 square root over 3m. So let it be inserted, 5 square root over 3m. This is 5 into 5 square root over 3m, and right side is just ma. Now m can be dissolved from everywhere. Here this m, as well as this m. Then sine 30 is half. Acceleration due to gravity is 10, so it is negative 10 over 2 minus 5 square root over 3 mu equal to a. Hence our acceleration at E is nothing but minus 5 minus, we may convert it into plus symbol, 5 square root over 3 mu. Square root over 3 mu, that is the final acceleration when the particle was 1 meter up. Well, so what are we going to write? We have got all three acceleration. Look at this. First acceleration at B, then acceleration at C, this is acceleration at C, then acceleration at E. So all three acceleration has been found. Okay, now we will find the velocity at each of the point, because velocity is different at every different point. Well, First of all, velocity at C, because velocity at B is same. Let's see how much was the velocity at B. Velocity at B was, yes, this one. Velocity at B was 2 square root over 5. So it will remain same because we have multiple times we have seen that the first part at B until B the section is smooth. There is no external force acting on this. So it will remain same. Just the difference is made in frictional force, frictional coefficients. As there is no friction involved in the first section from A to B, so it's all the same. Acceleration and velocity will remain same. So velocity is at B, velocity was 2 square root over 5. We can just write this V at, okay, at V, at B, velocity of V is equal to 2 square root over 5. Okay. Now velocity at C with different ink. At C, at C, velocity of C is equal to, you know how to find the velocity when the displacement is given, u square plus 2as. Okay, it is all about C. Let's see what are the information about C. Hence velocity at C is u square. Initial velocity at B was this, so we can insert this 2 square root over 5 squared plus, as acceleration is negative, look at this, at C acceleration was negative. This one is the acceleration at C. As this is, no, this is at E, acceleration was at C is this one. This portion is acceleration at C and it must be negative. We forgot to use negative symbol. So negative 10 mu. It is negative 10 mu. So it is going to be minus then 2 into 2 because the length of each of the section is 2 and acceleration is 10 mu. We have got 10 mu. Then velocity at C. So it is going to be, I think I should write just beside this. And erasing this, as this is the last sentence of this. So hence velocity at C. Velocity at C is going to be, so 2 square root over 5 square means 4, 4, 5, 20. So 20 minus square root over 20 minus 2 to the 4, 40, 40 mu, 40 mu. Okay, this is the velocity at C. Now velocity at E. We will have to find velocity at every point. So at, with different ink, at E, the final point at E, velocity at E is equal to, they have told us to find the mu first of all. So velocity at E is V square, the same formula, equal to u square plus 2as. Okay, final velocity, look in the question, what did they tell? After climbing or reaching 1 meter, it comes to instantaneous rest. So at rest, final velocity was 0. We'll just substitute here 0. Okay. So if final velocity is 0, initial velocity we have calculated here, it is square root over 20 minus 40 mu whole squared plus, it cannot be plus because acceleration is negative, so minus 2 into our acceleration. Let us write the length because it moved up 1 meter. Then S is 1 meter, length was 1 meter, and A acceleration, or let's see acceleration at C, not C, at E. Acceleration at E we have found here, look at this, this is acceleration at E. Acceleration at E, which is negative 5 plus 5 square root over 3. So we will, instead of A, we will write 5 plus 5. Let me erase this. So it is 5 plus, sorry, 5 plus 5 square root over 3 square root over 3, then mu, then mu. So this is our 2 from the formula. Acceleration is 5 plus 5 root over 3 mu. It was deceleration, that's a negative symbol. And S displacement was 1 because particle moved up 1 meter. So finally, what are we going to get? We are going to get, or 0 is equal to, it is going to be actually 20 minus 40 mu minus, if we multiply, it is going to be 10. 2 5s are 10, 2 5s are 10, then minus 10 cube square root over 3 mu. This is what our step is. Okay, if we simplify more, it is going to be, or 20 minus 10, it is 10, and it must be negative on the other side. 10 equal to negative, if you take mu common, it is going to be 40 plus 10 square root over 3. Then if we isolate mu is going to be, leaving this, discarding this negative symbol, it is going to be 10 over 40 plus square root over 3. 40 plus 10 square root over 3. Well, finally our mu is going to be, so this may be the last of all step for this part. Let the hence symbol be used. So our final value is going to be 10 over 40 plus 10 square root over 3. That means it is going to be 0.1744. So if we round it up to 3 significant figures, it is going to be 0.174 is our frictional coefficient of this part. They have told us to find the frictional coefficient, that means value of mu. So we have got the first part of this answer. Now the second part of the answer. What is the second part of the answer? Let me show you. First part was find the value of mu. We have got mu as 0.174, and second part, speed is to be obtained. So for speed, but speed, when to find which speed are they talking about? Speed of the particle. Let me show you. Yes, speed of the particle. Look, speed of the particle at the instant that it passes C for the second time. Okay, it is moving downward again. So what is the scenario? If I tell you the scenario, suppose this is, here is C. Okay, it is C and it was D over here, and the particle moved up to this point. Suppose this is our E. Okay, it moved up to this, then it is now coming downward, coming downward. So what will be the resultant force? This is normal reaction, and weight is pulling it, trying to pull it downward. Angle is, we know the angle was 30 degree. I am going to show you. The angle was, suppose this is angle was 30 degree. So what will be our concept to apply here? Simply they have told us to find the speed. So for speed we require acceleration. For finding acceleration, we always apply the same concept of the motion law of Newton. So let's find out the space to write this. Yes, we can write on the right side. So let me draw a divider line. Yes, over here I am drawing a divided line just over. Yes, let me take the stylus. Yes, so here we will we will solve the final part of this answer. Okay. We know that acceleration due to the movement. Let us see. Our concept is, what is our concept? Driving force minus driving force. The color of the ink will be this. Okay. Driving force minus resistance force. Let us show the direction of the force or motion. It is just moving downward. So our concept is driving force minus resistance force is equal to mass into acceleration. Well, driving force is nothing but weight. Look at this. When the particle was moving downward from this tiny figure, from this figure you can see that the particle was moving downward itself. There is no other or external force acting on this except weight. So weight is the driving force. We can suppose weight as the driving force. If we suppose weight as the driving force, so weight, the horizontal component of weight is what? Mg. We know mg sine 30 degree, because angle it was leaned. Look at this, it was 30 degree. How much was the angle? The angle was here. How much is the angle? Angle is 30 degree. Yes, at 30 degree, and the particle is moving down for the second time from 1 meter of distance, 1 meter of height, not height, length. So angle is 30 degree. We will write 30 degree, then after zooming out. And now frictional force, I mean resistance force. Resistance force is nothing, there is no external force acting on this except a frictional force. Frictional force is mu r. Okay, and mass into acceleration, mass and acceleration is to be obtained. Okay, mass can be, okay, m, and the sin theta is half, so it is going to be 10m over 2 minus our mu. We have already obtained our mu was, let us see the mu we have obtained. How much is the value of mu? Our mu is 0.174. This is our mu. Mu is 0.174. So let us write 0.174, 0.174 and r. Yes, 0.174. It is 0.174, 0.174. My stylus is not working well. 174 into r. Now frictional force can be picked up. We have already used this frictional force, not frictional force, normal reaction. R from C to, the normal reaction force is exactly same, because look at this, still there is no upward force is acting on the particle. That's why from, for CD it is written here, for CD the normal reaction force is still same. Still it will be what? Same, that is 5, because there is no other extra force is acting on this particle. As it was moving up and down, the same normal reaction force is active on this. Well, so it is 5 square root over 3. 5 square root over 3 m. Let us write this, 5 square root over 3 m into 5 square root over 3 m. 3m equal to mass into acceleration. Well, so finally it is getting 5, and all the m's can be dissolved from every side. So it is going to be 5 minus 5 square root over 3 into 0.174. Let it remain unchanged. 5 square root over 3 into 0.174 is our acceleration. Okay, or it can be written, okay, let me write in another way. This may be supposed to be the last part of this solution, not last part of this solution. This is last part of this secondary part. So it is, hence our acceleration is what? Acceleration is 5 minus 5 square root over 3 into 0.174 meter per second square. Look, we have not got deviated from our final answer. They have told us to find, what did they tell us to find? They have told us to find the velocity when it is moving backward again. Yes, 0.174. 0.174. Okay, so we will write, apply the same concept for the final part. Let me take the black ink. So while from E to C, now it is moving down. Look at this, it is sliding down and crossing the point C again. Here is the point. When it is moving down, it is just crossing this point. This is the point. Okay, at this point we will find velocity. And remember, when it reached 1 meter up, look, it came to instantaneous rest. So final velocity is, initial velocity was 0 while it is coming backward. So let us apply the same concept. V square is equal to, V square is equal to, hence V is equal to square root of u square plus 2as. Okay, hence our V is going to be, it may not be the final step, so we will write one more step. V is equal to, now let's see what was the initial velocity. Initial velocity was 0 and acceleration is plus 2 into, and displacement was 1 meter. Look here, it is visible, it's 1 meter 1, and acceleration when it was moving downward was 5 minus, so we can use this. Okay, 5 minus 5 square root over 3 into 0.174, 0.174, 0.174. Before that I will erase some part. It is going to be 0.174, 0.17 and 4, and there will be square root symbol covering everything. Well, this is what our velocity is going to be. So finally, if we calculate our velocity, it is going to be, so hence final velocity V is equal to, so let us multiply this, or let us write one more step. Let it not be the last step. V is equal to square root over 2 ones, 2 fives are 10. 10 minus 10 square root over 3 into that 0.174 into 0.174. So I will have to erase and write again. It is 10 10 minus 10 into square root over 3 into 0.174. Hence, our final velocity is going to be, let me use my calculator, it is going to be 2 into 10 minus 10 square root over 3. Yes, this is 10 minus, what was, it is going to be 2.64, 2.64 meter per second. So that is our final answer of this part. Let me show you whole of the solution, though it looks messy because the device doesn't allow to write so much on one page. Yet I tried to write, and I think you have understood. It's both A and B of this question are similar, almost similar to each other. At the final stage, initially, at every point, at point B, at point C, at point E, we have got both the acceleration as well as velocity. Then in the second case, the particle was actually sliding downward. That's why it is a little different. We have to thought it in from different viewpoint, but it's all the same, applying the concept of the motion law of Newton. And everywhere we have used the v square formula of v square is equal to u square plus 2as, because displacement as well as acceleration and initial velocity is known to us in every case. So that's all about the solution to the question number 6. It's a little bit lengthier. This is the first part, and the final part is this. Thank you all for being with me, and may Allah bless you with beneficial and useful knowledge. Fi amanillah.